Assalamualaikum warahmatullahi wabarakatuh. Greeting everyone. Let me introduce myself. My name is Shakyla from class Numerical Method 03. So in this video, I want to present my final exam from Numerical Method. Okay, so this is the first question, our first task. That is, we need to self-evaluating or muhasabah. Okay, so based on my muhasabah or self-evaluation, I assess myself quite well in this numerical method course. According to my reflection, I rate myself out of 81, 81 out of 100. So there are several reasons why I choose that score, that is 81, starting for my presence in my class, for my performance in class, and also my activeness in doing assignment. So first thing I want to discuss about my presence in numerical method class. So that Alhamdulillah, my attendance is more than 75%. Besides that, I also often collect assignment given by Mr. Dai, starting from mandatory assignment, voluntary assignment, and also major assignment. I have more or less method at 8 videos of assignment on time. So I mean, mutually. So while doing the assignment, I also become more understanding and try to understand everything learned in this class, such as optimization, Navier stocks, Reynolds laws, Bernoulli laws, CFD stuff, and many more. I also open up new skills in software where I tried myself using CFD stuff for my activity, performance, and my class. Actually, sometimes I feel doubt to speak in front of class confidently, but I still try my best to understand the lesson taught by Mr. Dai in class. Apart from the main components of the assignment, I feel that I deserve this score because I feel that I have sufficiently followed the teaching taught by Mr. Dai, namely the E5 method, where I always using this method to solve any problem or question. I also have uh, implemented the E5 method in my daily life. So for additional reason in managing my time, I can usually complete the assignment punctually with an evolution like this. I can identify area that need improvement and plan concrete step to improve my performance in the classroom. I need to be smart and manage my time, be more confident to argument in the class, and can be more explore myself to unlock my new skill. A new skill that I've been improved since I learned numerical method in history class are how to programming optimization using Python and also application of CFD soft. So for the conclusion, in my opinion, I rate myself 81 of 100, and overall my performance was quite good with some areas that need to improve. Okay, next. So, okay, so for question number 2, uh, we actually using a common intention from this intention is the component from the E5 method. So before working on the exam question, I first pray to Allah Subhanahu wa Taala, seeking ease and smoothness in completing question. I offer my individual prayer using this moment to surrender myself to Allah Subhanahu wa Taala. After the individual prayers, using this moment to surrender myself, I continue with joint prayer with my classmate from numerical method 03. So we start with istighfar, astaghfirullahaladzim, and asking Allah to forgive our sins. So following that, we recited to read surah ayat kursi and al-fatihah, which help calm our hearts and open our minds. So after performing the joint prayer, I was given time to reflect on myself, thinking about my attention. I deeply considering what exactly I wanted to achieve. Why about my why I'm here? What is my purpose to taking this exam? Also reflected on my past mistakes, seeking forgiveness from Allah Subhanahu wa Taala. The reflection brought forth many questions in my mind, making me more conscious of myself and the presence of Allah Subhanahu wa Taala. As I grappled with my thoughts for a considerable time, I eventually found my intention. I realized that I intended to complete the student the military application of string math assignment here. So yeah, this is the student military application of spring math system assigned to get now assigned to get to know Allah subhanahu wa ta'ala more deeply. This realization brought clarity and purpose to my efforts. In this assignment, we are asked to determine which of the three types of suspension system for STC is the most suitable and efficient. By carefully analyzing the working through this problem, I aim to not only fulfill my academic responsibility, but also to deepen my understanding and connection with God. Okay, next. So this is the next step, or our next question from the E5 method is initial thinking about the problem. So second step is initial thinking about the problem. And here we need to gather all of the data that given from the question. In this question, we are tasked with analyzing and recommending a suspension system for Rockwell Collins Satellite Transportation Terminal, or STT. The objective is to ensure the suspension system is not effective, reliable, and is cost-effective, reliable, and capable to protect the satellite during the loading the transport. To obtain this, we need to several data to accelerate. So this is the first question, general mathematical method. To simplify the analysis of the suspension system, we assume that the vehicle mass and any forces acting on the suspension are uniformly distributed, and the suspension system behave according to the differential equation. So here the equation. Okay. Next. From this equation, we know the xt is referred to displacement on meter. M is for mass of the object in kilogram, and B is damping constant in Newton second per meter. K is spring constant in Newton per meter, and the Ft is external force in Newton. So from the problem that we have to need to identify the data. So in this question is also we have several follow-up question. There's 5 actually. For the first one is model suspension of STT. So in here, as an engineer, we have tasked with evaluating feasible option for the suspension system of STT, and I have clarified the data that give, and then these are the 3 available shocks option. First one is or air coaster with K is equal to 220 Newton per meter, B is equal to 100 Newton second per meter. Second one is cloud riders with content K is 59 Newton per meter, B is 1050 Newton second per meter, and the last shock is extreme shock with K is 170 Newton per meter and B is 1110 Newton second per meter. And with known the mass is 1800 kilogram, and the XT or displacement is 3 centimeter. Okay, and here from this problem, we have a task. There are 3. First one is determine the critical damp value for each shock. Second one is solve the spring mass system, and the last one is discuss the model of each shock. Okay, so the second problem is non-homogeneous solution and shock performance. So we need to analyze and the performance is suspension system with the external force with the given data. So the given function is this given function is F is equal to 200 sin for omega t. So the assumption is, we have an assumption also which x0 is equal to 0 and x axis 0 equal to 0. And the task is first one is solve for non-homogeneous differential equation, find maximum and minimum displacement, and also determine the base shock. Okay, next. Okay, third is impact of endem shock. With the given data for premium shock is K equal to 225 meter per meter, B is 0 Newton second per meter. External forcing, same equation with the second one, which omega is decrease of roughness. And with task is first solve the initial value problem with variable T and omega. Second, determine the invalid omega, and three is interactive plot. And the fourth problem is response analysis, the given with the given data, t or time is equal to 60 seconds, mass is 4,000 kilograms, k is 5,000 Newton per meter, and here the equation of force equal to 300 cos t Newton. So we also have the task versus plot data and describe behavior. Second, estimate damping coefficient, and three is structural intensity check. Here the last problem is additional simulation with impulse, which with the given is number n is 13, omega 0 is 150 Newton, and mass is 1,800 kilograms with task. First is a model with direct delta function. Second is solve the IVP. Third, maximum and minimum displacement. And this last one is structural integrity for varied conditions. Okay, so we move to the next step, which is idealization. So from the data that we have gathered, we need to identify the formula, appropriate formula need to solve problem. So we need to write down the formula and understand how they're related to the problem. So yeah, same like this previous question. We have 5 problem in here. So first one is modeling the suspension system, which is for the question 1A is critically damped value calculation. So in here, we need to find the B critical, which the formula is 2 in K for each shock, which is for air course, we need to put the number, and also the cloud radar and extreme cloud, like in here we have the question here. Also for the second question is solve the spring mass system. We need the differential equation with the using a general mathematical method. So we can with this formula we can solve the given D and B critical. So the last one is discuss and compare based on the plots, and select the shock that provides the least oscillatory motion and best stability for a steady suspension system. So the second problem is non-homogeneous pollution solution and shock performance. The for 2A is the question is solve the non-homogeneous differential equation. We have the differential equation in here. It's actually same with general mathematical method, but the result, it's actually uh, is equal to 200 sin 40 using the similar chord structure. Solve the non-homogeneous equation and plot for each shock on the. Okay, so the B is find maximum and minimum, and C the determine the base and shock. Second problem is impact of undamped shock. So we have the similar question like before. Is actually to solve the initial value problem. We're using equation of ft equal to 100 sin for omega t. We need to determine the value of omega and interactive plot. Okay, next question problem is response-based analysis. So in here, we just need to plot the data give the data that we have gathered and put into. We use actually using software like Python, so we can see the plot that give from the data given. So yeah, this is for the question and or the problem for number 4 and 5. Okay, so here the instruction. Actually, in here, there are several questions that I've been looking, I've been find manually or I count in manually, and also there is a solution that using a Python. For example, like question for find a plot, the diagrams, and anything else. So this is the instruction. Uh, for number 1A is critically dim value calculation. So we can find the B critically is equal to 1,260. So we can, it's this for the air coaster, and then this is for the cloud riders. So yeah, for the cloud riders, we got the B critical is equal to 652 Newton second per meter, and the extreme shock is equal to 1,104 Newton second per meter. Okay, so the one equation is a spring mass system. In the spring mass system, we actually using the general method, a mathematical method, and we just need to put the given data into the formula, and for each shock, we need to find and calculate the equation one by one. For a coaster, we got the equation exponential uh, cos of omega t and C2 sin omega t. So the cloud riders we also get the for equation, and the extreme shock we also get the equation too. So the last one is 1C is compare shock. So all the coaster might show damping due to much lower and compared to its critical value. Okay, so this is the follow equation. For number 3 is a premium shock calculation, which known as K is 25 Newton per meter and B is 0 Newton second per meter. We also need to put the general mathematical method to the equation and put the number into the formula, and we got the formula or x5 is 200 sin for omega t per 25 2800 x square. From the question for number B, we got the omega is 0.0265. So this is the followed question is for number 4. For A, we need just you plot the given displacement. In here, we need to see the Python. So the B is I found it manually. So I got the omega is 1.118 radian per second, and this C is resonance hypothesis, which also I need to find the final omega. That is, I got 1 radian per second, and D is max displacement that I get is 0.5 meter. Okay, so the number 5 I also found it with the Python. So we need to see the Python. So here the code, the program or the Python that we have been looking for. There are several questions. This actually using a Python, especially for found the plot or diagram to compare each shock. So this is the first program that I have been looking for. Is solve the spring mass system. We actually the most important library that using for all of the program is NumPy and matplotlib.pyplot. So here the spring mass system we got a it's actually a graphic from the Python that we get is the blue one is air coaster, is the given damping, and the orange, I'm sorry, is air coaster critical damping. Is actually the given damping is under the critical damping. Also, the cloud riders, it is actually the given damping is higher than the critical damping, and the extreme shock is the given damping is also higher than the extreme critical damping. Okay, perform the graphic that we get, we can evaluate the air coaster might show less damping due to much lower B compared to its critical value, and the cloud riders and extreme shocks may exhibit better damping properties as their B values are closer to the critical damping coefficient. So based on the plot, select the shock to the prophet, list oscillator motion and base stability of the for the suspension system is actually we can get. Okay, so the second is solve the non-homogeneous differential equation. In here, we got the also the plot. So yeah, this is we also using a library as NumPy as and matplotlib.pyplot. Okay, in here the code solve. For blue one is air coaster, yellow is cloud riders, and the green one is an extreme shock. You can see the displacement from the air coaster is actually higher than the other shocks. Okay, so this is the uh, code or program for find the maximum and minimum displacement. And this is the program for our third question is which is impact of undamped shocks. So in here we also get this is the graphic from the displacement, and we actually get the omega from the graphic, which is air coaster. Is omega is equal to 0.5. And then the yellow one is crowd riders, is omega is 1, and the green one is extreme shocks is equal to 2. So next one is azimuth damping coefficient. We also get the graphic. Okay, so we can go back to the question. Okay, so that's the last question from this exam. So think alhamdulillah we can finish it with alhamdulillah. So that is all from me. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.